This conference will now be recorded. This conference will
Online
now
people,
be
please
recorded.
record the session. Yes, thank you. So 2 agendas was completed. What is Snowflake? What is Snowflake? And what is cloud computing? Cloud computing. What is Snowflake and what is cloud computing? Yesterday we done with these two agendas. So majorly we all know that what is Snowflake means. It is one type of database. What is Snowflake means? It is one type of database which will act as centralized system, centralized repository, which will stores the data coming from different range of sources. Is a one type of database, but database is not a database, one type of database. Okay, it is a one type of database which will act as centralized repository, which will store the data, which will store the huge data, so that it will be meaningful. Huge data or bulk data, bulk data coming from different range of sources. Okay, called as data warehouse. Sources. That's it. So this is the simple definition. As I said, like it is one type of, basically Snowflake is a data warehouse. It is a data warehouse, cloud data warehouse. So instead of going with a cloud data warehouse, I just explaining the data warehouse. So data warehouse is a concept called one type of database which will act as a centralized repository which will store the huge and bulk data coming from the different range of sources. Simple definition is called as a data warehouse. And what it mean by cloud data warehouse? Nothing but combination of cloud computing and on-prem. It's like nothing but combination of cloud computing. Data warehouse is a combination of cloud computing. Data warehouse is a cloud computing. Cloud data warehouse is nothing but combination of a software, a Snowflake software, as a software with a cloud computing. This is the cloud data warehouse is nothing but combination of software with a cloud computing. Now, how many types of data warehouses we have? Types of data warehouses. Types of data warehouses. Two types. One is, tell me, two types. One is on-prem. Another one is cloud. On-prem and cloud data warehouse. On-prem data warehouse and cloud data warehouse. Do you know the difference between the on-prem and cloud? Diff between on-prem and cloud. Difference between on-prem and cloud. I already explained you on-prem differentiation and cloud. But again, I am repeating, on-prem is nothing but in IT industry, we need a resources. Okay, all the resources are maintained on company premises only. That we call it as a on-prem. Okay, on-prem means all the resources are maintained on company premises only. On-prem is nothing but all the resources maintained on company premises only. Cloud is nothing but nothing but all the resources maintained on some other place, and and that resources will be accessed via internet by users. You got my point? So no need to worry to write all these things. I will share the screenshots. Whatever the returning and the documentation, everything will be maintained on your screenshot. But I don't want to interrupt you. If you want to write your long notes, you can write with your own notes. Okay. But whatever I am writing, I will share this screenshot. Okay. Don't worry about it. So this is called on-prem. On-prem means we need some resources like routers, switches, IoT devices, sensors, CPU, memory, storage, RAM. These all are the resources. These resources are maintained on the company premises only. That we call it as an on-prem. Okay, but all these resources are maintained on some other place. Okay, that refers to a cloud. Okay, via internet you can access it. That we call it as a cloud. Simple and short. Now tell me, what is computer? What is computer? It is very simple question. From childhood onwards, we are getting this question. So what is a computer? What is computer? So in childhood, we say that what is computer means we can say lot many things like monitor, CPU, RAM, mouse, keyboard, even keyboard pad also we will say in childhood. Our computer teacher will teach like that only. Okay, but in on-prem we call like same. In on-prem we can say like that only. Don't worry about it. That's not wrong. But coming to the cloud, in point of cloud, computer is nothing but having a computing power, like CPU and RAM. CPU and temporary storage memory. Processing power. Computing nothing but having a processing power. Computer is nothing but having a computing or processing power. So compute plus temporary storage. Temp storage. You got my point? Computer is nothing but compute plus temporary storage. So no need of storage, no need of RAM. So here in my laptop, have a storage of this much, 500 GB. So for computing, no need of storage. For example, if I want to create some operation, okay, I want to show the CPU performance. I want to check the application status. I want to open an application. No need. If you want to do some operations in the application, no need of storages. When you need a storage, if you want to maintain some data for feature reference, like for example, I'm making the documentation for this feature references like Snowflake, everything. Feature reference. That time I need storages. Without the storage also we can use our computer power. Yes, for seeing the movie you need a computer power. For browsing something in internet you need a computing power. No need, no? Not at all. So further, computer means it's having a temporary storage. So small storage is enough, and capture memory is enough to do the operations. You got my point? Now, what about the storage? Again, storage is different. There is a external storage. Call it as a external storage. External storage. Storages like lot of things are there in on-prem like cloud. So, for example, external storages like NAS, SAM, magnetic tapes, floppies, floppy, pen drives, hard disk, STDs, SSD, CDs. Same, these are the external storages. So coming to the cloud computing, cloud storages. Own storages having. They are having individual storages, individual own storages. I will say that as a individual own storages. Let's say example, individual own storages. Example, cloud vendors are cloud vendors are AWS, Amazon. Okay. Next, Azure, Microsoft. So, next, GCP. Google, no? So why I am writing only these two, three? We have some other cloud storages also. Cloud vendors are there. So like for example, OCA, Oracle, Salesforce, and some people having own cloud storages, own storage cloud. So okay, but why I am specifically mentioning three cloud vendors, only three cloud vendors? Why? Because Snowflake supports these three cloud vendors. Snowflake supports to these three cloud vendors. Snowflake supports to these three cloud vendors only. Clear? For example, coming to the storages, cloud storages, coming to the cloud storages. So coming to the EC2. EC2. So AWS, what I will do, I will say it as AWS. Okay. In AWS, we have a EC2. EC, sorry, S3. S3. Storage is S3. Next, Azure. Storage is like Azure blobs or data lakes. Okay. And coming to that, GCP own storage, GCP cloud, GCP storage. Still, it is not popular. Okay. These are the storage part of it. Coming to the computing part. Coming to the computing part. What are the major computing part? Color is this one, okay. Computing part. You got my point or not? I'm confused. No, clear. Computing part. AWS, EC2, server. Okay, computing power. Azure, VMs. Okay, VMware. We call it as a VM. In GCP also we call it as a VM. GCP also we call it as a VMware. These are the computing. You got my point or not? Now tell me, cloud data warehouse. Now tell me what is cloud data warehouse. Previously we talked about a cloud data warehouse. What is cloud data warehouse? It is a combination of cloud computing. Cloud data warehouse is called as Snowflake. Snowflake is the one of the best cloud. There is a lot many. What are the cloud? What is cloud computing? Examples are, for example, Snowflake first, Redshift. What I will do? Just take the cloud data warehouse. I just copy. I'm sorry. Can you please repeat again? That is somewhat cloud database. So why I copied means for this. See, in Snowflake is one of the most popular, easy to use data. In Google itself, I am saying this.
When GCP belongs to that piece,
Snowflake is one of the most popular and easy to use data warehouse out of the Google BigQuery, Amazon Redshift, Azure Synapse, IBM DB2 warehouse, Fireplot, even you said that Ivory. So there we have some Teradata is there. Okay, there's a lot many cloud data warehouses. But why these guys are saying, not Ravi saying, why these guys are saying Snowflake is the most popular and easy to use data warehouse out of there, and it is the best. Why? So my question is, cloud data warehouse, nothing but the data warehouse used on cloud. Previously, I talked about a data warehouse that are in on-prem. That means all the resources will be maintained on-prem. If you want to maintain a storages, the resources will be on company premises. But coming to the cloud data warehouses, all these resources will be maintained on cloud, some other place. Via internet, we can access it. First of all, you need to know about and clear about it. If you want to use a Snowflake or data warehouse, Snowflake data warehouse or any data warehouse, what we need most of it, two things. One is computing power and other one is storage. Computing power, why? To maintain something and to process, to make a query, to optimize it, to run the search, to retrieve the data, or to transform the data, to extract the data. We need this computing power. Yes or no? To process this, all these things, we need a computing power. And coming to that storage, yes, we are maintaining bulk of data coming from the different range of sources. Where we will maintain the data? That will be maintained on the storage only, na? So that storage needs one. That means computing power, computing. That's why I'm telling you lot many times. Computing power, computing plus the storage I need. This will be on-prem, on company premises. Okay, only that's we call it as on-prem cloud. On-prem. If you maintain this on some other place, via internet, you can access internet. You are accessing. That refers to cloud data. Cloud data. Simple and short. So cloud data warehouse is a one type of data warehouse, okay, which will be combination of cloud computing. Okay, all the resources will be maintained by a cloud vendors, okay, and this will maintain the bulk of data and bulk of storage on their storage capabilities, okay, and they can process our data with a computing power, and this we call it as a data warehouse, cloud data warehouse. Clear? So that's the first point. Now tell me, we have a lot many cloud data warehouses are there. Why we are going with a Snowflake? Why Snowflake? Why Snowflake? Clear? So up to now, do you have any questions? You can ask me. I will give chance for next 2 minutes. Please ask your questions. Up to now. Up to now, do you have any questions? Please ask me. Online people.
This
Class, I
conference
will
will
give you
now
5
be
to 10
recorded.
minutes time. After this class, I will give 5 to 10 minutes time. At that time, you can clear your doubts apart from the subject. Okay. So up to now, do you have any questions on the subject? Yes. Now, before going to go with a why Snowflake, just I will show you one image. So where we are exactly. First of all, how that modifications came, why we are going with cloud computing, where we are started, and where we are. Okay, we will discuss that things. So all the companies having a lot many applications are there. Okay, so they've used a lot many applications and they have done lot many transactions on their applications. Okay, to maintain that application law of transactions and everything, they need a database. So we have a database called OLTP database. So OLTP databases, we call it as OLTP databases. And that OLTP databases, we have two types of databases. What DBs? We have a lot many, but majorly I am talking. Okay. So we are not going to digging on from scratch itself. So just what we have. Okay. OLTP major RDBMS and NoSQL. RDBMS and NoSQL. Whereas RDBMS is relational databases. NoSQL means NoSQL. Okay. Now, for example, we have an Oracle database, DB2, MySQL. These all are the RDBMS databases. Whereas NoSQL databases call it as a MongoDB. MongoDB. Now, we have a RDBMS databases. Why they are trying to introduce a NoSQL databases? Because there is some lack on RDBMS databases. Why? Because RDBMS databases are weaker in capacity and weaker in performance. Okay, somewhat better performance, somewhat better, but weaker in capacity. They want to maintain huge data or bulk data. Weaker in capacity, RDBMS databases. Okay, now NoSQL databases, come to the NoSQL databases, they are stronger in capacity. Okay, and performance is also okay. Performance wise also okay, but stronger in capacity. You got my point? Now, but people are looking for the RDBMS even though it is weaker in capacity. Why people are looking for RDBMS databases only? Why? Because NoSQL databases are weak in batch processing. You got my point? Even though it is weaker in capacity, people are preferred RDBMS servers only, RDBMS databases only. Why? Because NoSQL databases are weaker in batch processing. What it mean by batch processing? Before that, you need to know about, we have two processes. One is online processing and other one is batch processing. Online process and batch process. What it mean by online process and what it mean by batch process? Online process means user interactive transactions. User interactive transactions. Batch processing means user non-interactive transactions. User non-interactive transactions. You got my point? Yes or no? What it mean by user interactive transactions and what it mean by user non-interactive transactions? User interaction transactions means, the example, let's say for example, you have a HDFC bank. HDFC bank users are checking for their balance, okay, and transaction information, statements, mini statements, and transaction information and everything. A user-wise transaction checking, this all will be under online processing. End of the day or end of the month, a manager will check the entire user's process. What is the user's response? What is, how frequently they are checking entire user's response. Okay, that we call it as a batch processing. Simply, online means real time. Batch means historical. You what means? Historical. Old. At the end of the day, old data only, no manager will check. But user is checking for the latest, current one. Yes. User interactive means online. User non-interactive means batch. This, yes. Actually, we have two types of databases. One is RDBMS and other one is NoSQL. RDBMS are weaker in capacity. Performance wise okay. NoSQL databases are weaker, stronger in capacity. Performances are okay. But Capacity is high now. Why people are not preferring the NoSQL databases? Why people are preferred only RDBMS even though they are weaker in capacity? Because NoSQL databases are weaker in batch processing. Batch processing weaker. So for that reason, so many users, so many clients are preferred for RDBMS. Most popular databases are RDBMS, even though they are weaker in capacity. After that, NoSQL databases was introduced also. They preferred RDBMS because NoSQL databases are stronger in capacity but weaker in batch processing. What it mean by online and what it mean by batch processing? Online means user interactive. User interactive. Batch means user non-interactive. For example, online means a user is checking for their own balance, own transaction, own information. That is the user-based transactions, like latest and real time. Okay. Whereas batch means a manager will check the end of the day, a manager will check entire user's information. Like what is the statistics of your users and everything. Okay. That is historical data, old data. That's we call it as a batch processing. So whereas NoSQL databases are weaker in batch processing. You got my point? Whereas SQL, RDBMS are both are performance good. Weak online and batch processing performance are good. That's why people are looking for RDBMS. So anyways, whatever the database should be, whatever the database, they are exclusively made for maintaining the transactions, maintaining some stuff on the database. Yes, sir. But these databases are exclusively maintained or exclusively created for writing speed. All the databases are exclusively created by writing speed, not for reading speed. You got it? That's why databases will maintain data faster. If you want to go and search the data on databases, so that will give some performance by slower. Why? Because it is doing some processing on the database. Again, you are doing on some other processing. That time the performance will be weaker. That way you will get effect on performance. You got my point? You are doing some work, man. I am saying some work, some more work. What will happen? Whatever it won't be perfect. Whatever the first work won't be perfect. Why? Because you are made for one work, exclusive. Yes, you can do some second work also. But you are doing one work and then you are making a second button work that will give you a performance now. Effect on performance. Same like that. Databases will make it writing speed and it will maintain all the transactions, latest and continuous transactions from the databases, from their applications. Again, you are making some transactions on the database to search and make it some query. So that will affect your performances. Okay. So that's the measure. So for that reason, what they will do, and one more important thing, and these are maintained with the latest data. Like for example, if you talk about HDFC Bank one, they will give you last 5 year statement. No, they will provide only last 1 year statement or 2 year statement. If you want last 5 to 10 year statement, you need to go to bank. From there, they will go through the second servers, like backup servers. From there, they will retrieve that your bank statement and they will provide. Yes, sir. They won't maintain a bulk of data or old data or historical data on the databases. Only latest transactions and the latest, some period based on your company requirements. It is company wise difference. Some people maintain 1 year, some people maintain 2 years, some people maintain 3 years. Retention policy. Okay, and the remaining data entire will be maintained on backup. Where that will be backup. Why they are need to be backup? For feature purpose. For feature purpose. So databases are for latest purpose. Now present purpose. That we call it as OLTP. OLTP is nothing but online transactional process. Databases are made for OLTP. Online transactional process. Online means Online processing, user interactive process. You got my point? So now that's why what they will do, they will create one databases. They will create a databases. And whatever the old data will be moved to the data warehouse. Whatever the database data will be moved to the data warehouse. Okay. So data warehouse is nothing but we not at all we introduced data warehouse. Just we are saying that data warehouse. Data warehouse is nothing but backup, centralized repository. Bulk of transactions will be coming from different technologies will be maintained on one place. At the earliest stages, earlier means first of the stages. What they will do, they will use magnetic tapes and sandbox and floppies to maintain the data. Whatever the historical data will be maintained on magnetic tapes, SAN storages, and floppies. You got my point? At that time, the process and upgradation and maintenance will be very headache process. Why? Because, for example, if you talk about the magnetic tapes, if you want to go with the maintenance mode, whatever the entire data in that magnetic tape will be moved to some other storage, and that will be maintained, and we need to move again. Headache process. Headache process. Magnetic. That after that headache process, they introduce a data warehouses. They introduce a data warehouses called Teradata, Netezza, and Vatica. There are lot many, but I'm talking about popularity. So Teradata, Netezza, Vatica. Vatica is supports for less than 200 TB. Less than 200 TB. That means Vatica data warehouse will maintain up to 200 TB, less than 200 TB. But if you want more than 200 TB, then they will use a Teradata and Netezza. Teradata having a cloud also, but these all are on-prem. Just I am saying up before cloud. When the cloud was introduced, do you know that one? Do you know that one? Cloud started here, 2006. I'm talking about before 2006. Okay, before 2006, I am talking. This is 2006. Cloud computing was started. Talking about before 2006. So at that time, 2006, I am studying on 7th class. Yeah, same thing. 7th class. At the 7th class time, I am talking. Yes, 7th class time, floppies are very famous. Very famous. CDs, artists, very famous. Magnetic tapes. Very famous. 6th class, 7th class, we will use to do magnetic tapes and floppies. CDs, floppies. CDs also not came at 10th class range. I think 2007, 8 at time low. At that time, CDs are came. But first starting is floppies and magnetic tapes. Magnetic tapes means you have a tape now, like MP3 songs tapes are there now. Cassettes, we call it as cassettes. If it is something with it, definitely we need to maintenance will be very high. Yes, that will be. If it is corrupt also, it will be having some scratches also, it won't. Okay. Before 2006, I am talking. So magnetic tapes. Let's say 2000, I am saying the 2000. And after the Teradata, Netezza, Vatica came, at Vatica it only less supports to less than 200. But it will be supports. But somewhere it don't have it. For example, if you want to make a 1000 TB, not possible for this Teradata. The burden will be very high, and the process will be slow. Okay. And even whatever the Teradata, Netezza, Vatica data warehouse is also not supposed to supports. Not supposed to supports for bulk data. Again, I'm repeating. Even they introduced Teradata, Netezza, Vatica as a data warehouses, they are not supposed to support for bulk data. Performance issues coming. Okay. In 2000, Even after cloud computing also, they are using, even 2006, we have introduced cloud computing. Nobody used cloud computing on that time. Okay. I think 2012, 10, 12, at that time, they introduced, they got popular on cloud computing. Even though it is got 2006 also, they was popular on 2010, 11 like that. Okay. So now my question is, Edu. Edu started here. 2010, I think. 2005. 2005. That means before cloud, 2006, we have introduced cloud. See here. Cloud introduced on 2006. It's not your class. Edu introduced on 2005. Edu is on-prem. I'm not talking about a cloud still. Why? Because I'm still on-prem. These all are on-prem. Okay, I'm still on-prem. Now I am in 2004. Let's say 2004. This one. Now this is 2005. Now these are in 2000 maybe. This is the 2000 year. This is the 2004, and this is just example. This is 2005. Now these are not supposed to maintain a bulk of data, so that's why Hadoop systems was introduced. These Hadoop systems are on-prem. In 2005 it was introduced, and it will maintain bulk of data. How they will maintain bulk of data? Why? Because storages will need it. Maintaining of storage is purpose here. Okay, not computing here. Computing is another process. But first I am talking about storages. Okay, data is exclusive for storages. Okay, in this case, storages I am talking. Where Teradata, Netija, Vertica are not supposed to bulk of data. Why these Hadoop systems are support to the bulk of data and huge data? Why? Because these are complete clusters. A combination of nodes. Nodes means one server. One node called one server. 10 nodes called 10 servers. 100 nodes called 100 servers. 1000 nodes called 1000 servers. These 1000 nodes combined called as a one cluster. That means these 1000 servers. For example, one server you have a 500 GB. You will keep one more server. You will keep one more server. Like the 1000 servers. 1000 servers into 500. That entire we call it as a storage. That's it. On-prem clusters, 1000 nodes. Combinedly, 1000 nodes are n number of nodes. N number of nodes will be combined as a one cluster. It will maintain as a storage. That's why Hadoop is most popular and very popular on big data analysis. You got my point? Now Hadoop was introduced and they will maintain a bulk of data. Okay. But on the top of the Hadoop systems also, if you want to store a bulk of data from different applications, we are getting lots of data, lots of data. Nowadays data is very huge, man. Okay, the data is coming from lots of applications. The bulk of data is coming to the Hadoop. Hadoop systems also will be slower to process the data. Hadoop systems will be slower to process the data. At the time, Hadoop systems will introduce a Spark. This Spark is used to process bulk of data at one point of time. To speed up the process into the Hadoop systems. Spark is the another software. So with Hadoop and Spark systems, okay, they will maintain bulk of processing data into a big data process. Clear? On that big data also, see, people are looking for the cloud. Why? Because everything will maintain on that on-prem means, on cloud means, on premises means, you need to take care of this maintenance and you need to keep a maintain admin for them and you need to make a climate for them. Like climatic control is there now for AC and everything you need to keep now, and maintenance overhead, investment of money is overhead. Okay, unfortunately, my project was gone. All will be wasted. Okay, if any disaster recovery is there, not possible. Yes or no? And these are all the headache things. That's why people are looking for the cloud. That time in 2006, this cloud was introduced. Okay, all people are wow. All company people are say that wow. But unfortunately, in 2006, it's not popular. Up to 2012, I think 2011. Hadoop systems only popular on 2010. Even though it is introduced on 2005, after 5 years only it was got popular. Same like that, cloud computing also popular on 2010, 11, 12. Okay, every software needs time to pop. Okay, but we need to believe now. For example, some people release some product. People won't believe that product. After some days, we will believe. We'll start believing. Same like that. Yes or no? So in 2006, cloud data warehouses was it. Not data warehouse, not a cloud. Data warehouse is nothing but storage, man. A cloud introduced. Now all company people are says that wow. And then people are starting using a cloud. So no need to maintain anything. Everything will be maintained on some other place. We will just use the resources, and whatever the usage you have, that for that you need to pay. Based on your usage, you need to pay. Based on your usage, you need to pay. You got my point? So for that, people are relaxed and looking for the cloud. On the cloud, we have a Snowflake. We are talking of data warehouses now. In that AWS, Azure, Microsoft services are there, Azure, GCP are there, and Salesforce, OCI are there. I'm talking about data warehouses. That's why data warehouses like Snowflake, Redshift, BigQuery, Synopsys, Teradata. These all are the, even Teradata also introduced the cloud after that. So Teradata, it's all a cloud.
Mostly Snowflake is related to
Yes, why Snowflake? I didn't come to that. There is a lot of benefits we have. Why we are going with the Snowflake? I will tell you. Just I am going with introductions. So once you go through these activities, these all are the cloud data warehouses called as a modern data warehouses. Called as a modern. Why people are looking for modern data warehouses instead of going with a Hadoop, Spark, and what Teradata, Netezza, Vertica on-prem data warehouses? Why? Because unlimited data will be processed. Okay, storage, bulk of storage you can maintain. Process speed also high, and what it mean by optimizers? I want to clear about the optimizers now. What it mean by optimizers? Let's say, for example, you write one query. To execute the query, you write one query to achieve some results. That execution cost will be a 1 hour. Okay, you X person written one query, that execution cost for 1 hour. But Ravi written one query with the same strategy, but my query execution cost is only 15 minutes. What is the problem? Query problem. Same process, same server I am talking, but you written query is taking 1 hour. What are I returned query taking 15 minutes? Why? Because query problem. I written somewhere difficulty of query. You written somewhere difficulty of query. Query problem. You just change some fine tuning on your query, that will take 15 minutes only. Changes. That automatic optimizers, optimizing means that optimizing, time optimizing, will be having a modern data process. You want automatically optimize your query. That we have a modern data. Clear? Now, sir, Amazon having a Redshift, Azure having a Synopsys, Google having a BigQuery, Teradata have a one company. Why people are looking for Snowflake data warehouses? Before going to that, this is the purpose of any data warehouse, and it will maintain bulk of data coming from the OLTP systems. But unfortunately, These OLTP data systems are sending to the data to a data warehouses, but somewhere the processes are slower, but because the button is taking more on processing the data into a data warehouse from multiple stages. Yes or no? For categorization, transformation, everything will be done with the data warehouse means it will take some effect on performances. That's why what they will do, they will introduce a ETL processors. They'll introduce a ETL process. Clear? So ETL tools in middle of OLTP systems and data. What ETL tools we have? Informatica, data stages, Talent, MSBI, SSSI, ADF, Scoop, lot many EDF, lot many tools are there. But this purpose, whatever the ETL purpose is, to extract the data from OLTP systems. Okay, OLTP means databases, and then transform your data. Transformation means requirements. For example, let's say filtering and modifications and customizations will be done with called as transformation. Loading means target tables called databases. It will extract the data from databases and transform the data and load the data into a data warehouses like on-prem and cloud. Clear? We are using a cloud. You are using it on-prem. So there to get good performances, we will use an ETL process to extract, transform, and load to the data warehouses. Clear? Any question? Now, these are the major things. Anyway, if these are extracting the data and these are transforming the data and these are loading the data into your target tables, even though you are getting a bulk of data from the data warehouses, that time ETL process will slow. Small cases I am saying, this is small cases, directly data warehouse will be connected to a data warehouse. In somewhere bigger cases, we can use the ETL process. In more huge cases, ETL also will be performance issues. That will be stuck to process bulk of data. So to process bulk of data from ETL to the data warehouses, we will use a Databricks. We'll use a Databricks. Instead of Spark, in on-prem, they are using Spark now. In cloud systems, they are using a bulk processing database.
So ETL, they use the Databricks.
ETL, without ETL also you can use database. But purpose, you need to talk about the purpose. Somewhere some people will, for example, if you talk about the cloud, no need of ETL process. ETL process will be done with the cloud data system. You can transform the data, we can extract the data, we can load the data into different tables and schemas. Okay, that's what. If you talk now, it will be mistake. If you talk tomorrow, it won't be mistake. Why? Because time be considered. Now it is wrong. Something will be happen. That time tomorrow you talk. For example, a man was died on tomorrow. You talk today itself. This man was died means that will be mistake. Tomorrow evening you will talk. Yes, you are correct, man. That's what time considered. So based on the time you are talking here. So Databricks or anything. So for example, if it is small processing, no need of ETLs. If you are not hitting on-prem, no need of cloud. People still using on-prem. Yes or no? People having some exposure, then only all will come. So that's what the thing. Clear? But the purpose of Databricks is to process bulk of data into your target tables, like a Spark. Okay. Now, whatever the data will be maintained on the data warehouses, then a Power BI, visualization tools, data scientists, data engineers to like giving a predictive analysis or visualization or reporting, alerting, dashboarding, or mining or monitoring. They will integrate with the data warehouses and they will face that. Yes, sir. Power BI and Tableau, these are directly connected with the databases now. Why data warehouses? Yes, nowadays people data is short. On online processing, you can directly connect with your Tableau and Power BI with the data warehouses, databases. What about batch processing? Bulk of data, historical data, 30 years of processing, Tableau will be blast. Yes, sir. It won't even databases won't support further. So that's why data. Okay. For example, in my home, in my mother's home, it is very empty. My mother's home is very empty. Why? Because they won't use anything. They just go to the farming, okay, and they come and slap. That's it. But coming to my home, I have one little child. He's playing. So I have a lot of things to play. I have one big car also. That car will be in storeroom. Why? Feature purpose. For next 3 to 4th year, he use that car. Feature purpose, I am making a storeroom. Okay, whatever the play toys, all will be maintained on storeroom. Why? Why I don't throw on outside? For feature purpose, maybe I have some second shade. He will use that. Yes, storeroom. Our warehouse, we call it as storeroom. We call it as warehouse. Simply warehouse. Data warehouse is nothing but maintaining a bulk and use historical data into a centralized system. From there, it will serve to the multiple purpose. That we call it as OLAP. OLAP. Database. And that's why I say that data warehouse is a one type of database. Database is made for OLTP, online transaction process. Data warehouse is made for OLAP, online analytical process. You got my point? For feature reference, for feature purpose, for creating reports, visualization, statistics. This is called a story of. Now, why Snowflake? We will see on tomorrow. We have a lot many softwares are there, but why people are going with the Snowflake means we will see on tomorrow. Do you have any questions? Please ask me. Online people. Online people. Do you have any questions? Please ask me. This is what tomorrow agenda is. Why Snowflake instead of all those Redshift, BigQuery, Synopsys, Teradata, and everything. Clear? Online people, this is the last call. Do you have any questions? Any question regarding course or regarding other activities also you can ask me. Management people, please stop the recording. Yes, please.
Can I speak in Telugu?
Yes, please. Telugu. Okay, fine. No problem. SQL Server and MSBA courses. Basically, SQL Server is a database, and there we have a data warehouse also there. Okay. Whereas MSBA is like a ETL process. So, if you learn the SQL Server, where you are going on basics of SQL Server. That time you are in databases. If you are going with the MSBA, SSID, then you are in ETL process. If you are going with the SQL, Microsoft SQL Server, data warehouse is also there. Okay, that time you are in this place. That means on-prem, not cloud. On-prem. So here, if you want complete course details of this one, you can connect to the management people. I am not supposed to explain this course here. Yes, please speak in Telugu. No problem. I can speak in Telugu.
Yeah. మీరు చెప్పే కంటెంట్ తో మనం రియల్ టైం మేనేజ్ చేయగలం. ఐ మీన్ ఇప్పుడు ప్రజెంట్ వర్క్ ఫ్రమ్ హోమ్ లేదు కదా, అంటే ఆఫీసెస్ వర్క్ చేస్తున్నారు. యాక్చువల్గా బ్రేక్ పెడితే మనం మేనేజ్ చేయగలం ఆఫీస్కి. హలో హలో